Here we have a T-shaped cross-section, and determine the distance of the centroid from top of the section, as well as the moment of inertia for the section shown in this figure. Okay, so to determine this, we need all of this information given here, and we need to preset the location of the centroid, and then we're calculating the distance from top to it. This is a y bar. Right. To do this, we need to cut it. I cut it from here. I then get area 1 and area 2. Okay, we set this is the centroid, right? So we're calculating this y bar, and based on that, we will just need to find out the moment of inertia of the section. Okay, so before that, we cut it into 2 subsections, and for each of them, it's easy to find their local centroid, right? Since each of the subsections are just rectangles. Okay, so the centroid of subsection 1 is just here, and subsection 2 is just here. Okay, so this will be our y1, and this is our y2. Okay, so based on this, we can easily calculate finding out the value of y bar. Okay, it's will be very convenient to use tables. Okay, to use tables to find out y bar and calculate the Ix. Okay, for the first step, we're looking for the centroid. Since x bar is not needed, right, because this is symmetric and your centroid here is right on the y-axis, so the y bar will not be needed to be found, right? So we are only need to calculate to find out y bar. Okay, the y bar is just a sum of ai yi over sum of ai. Okay, so from here we will use a table. Since we have cut it into subsection 1, subsection 2, for each of them, we will try to find its ai, yi, then calculate ai, yi. Right, for area 1, what is the ai? The a1. Area 1 here, you have 1 times 12, right? So 12 times 1 equals 12. And what is the yi? Yi is just a half of the thickness, right? This is 1 over 2, that is 0.5. And ai, yi will be just 12 times 0.5, that is 6. And then for sub-area 2, here you have 10, you have 0.5, right? So just 10 times 0.5, you've got 5. And the yi from top to here will be the whole thickness of subsection 1 plus half thickness of subsection 2, right? So that will be 1 plus 10 over 2. Right, this will be 6, and the area here will be 30. Then we calculate their sums, where we need sum ai. Sum ai will be 12 plus 5, it will be 17, and we need sum ai yi. Here will be 36, right? Then here y bar will be equal to 36 over 17. That will be 2.12 inch from the top. Right, so this will be the location of the centroid from top. Right, from here to the centroid, this distance is 2.12 inch. Okay, we have determined the location of the centroid. Then let's look at the moment of inertia for this section. The second step, we're calculating moment of inertia since for this type of shape we will never bend such T shape about Y axis, right? We never do this. Can you imagine that you bend it you bend it about Y direction? It will never work, right? So we'll only calculate Ix, right, about X direction. We will bend it about X direction. Okay, so we're calculating Ix. So that would be, based on our equation, sum ICX plus AI DI square. Okay. Again, we'll just use a table. We have sub area 1, sub area 2. And for AI DI, or AI DI, AI we already have, right? AI is just 12 and 5. 12 and 5. And DI, what is D1? Okay, so what is D? Right, D is just the distance between two axes, right? For D1 would be just the distance from this axis to the overall x-axis, or the distance from the local centroid to the overall centroid. Okay, so this is our D1, and this is our D2. Okay, the D is actually the distance between the local centroid to the overall centroid. Okay, so what is the D1? The D1 will be the y bar minus y1, right? So this will be just y bar minus y1. What is y1? y1 is 0.5 and the y bar is 2.12. Right? So this will be 2.12 minus 0.5. You got a 1.62. Right? So what is D2? D2 will be y bar minus y2. Right? 2.12 minus 6. Right? This will be 3.88. Right? Then we can calculate AI DI square. Okay, so just based on these numbers, it's 4 numbers. Here you will have 31.5. Here you will have 75.3. Okay. Then we have determined AI DI square. We also need to calculate the ICX. Okay, ICX. So here's IC equals BH cube over 12. Right, for area 1. For area 1, the B is 12. And the H is 1. Right, just a 12 times 1 cube over 12, that would be 1, right? Then for the area subsection 2, the B is 0.5, the H is 10 over 12, and that is 41.7. Okay, then we can calculate the sum values, right? So for the first one, right, this will be part 1 will be here 1 plus here 31.5, right, plus part 2 41.7 plus here 75.3. Okay, the result will be 149.4 inch to the fourth.